Hello, everyone. My name is Oskar Dudycz, and we'll be talking today about the privacy, GDPR, and all that stuff. So happy that you joined our webinar. We will be explaining all of the bits and general strategies on how to handle GDPR, privacy, and all that sexy things. So I hope that you are seeing me and you can hear me. So let me just hide a bit my face and let's go. So few words about myself. My name is Oskar Dudycz. I'm a developer for over 14 years. I'm an architect, and currently I'm working as a developer advocate at EventStoreDB. So I went all of the journey from the junior developer, meteor, senior, technical, and architect. And lawyers are saying that Googling stuff doesn't make you a lawyer, but programmers, of course, we like to Google, we like to ask, we like to chat. So one disclaimer, I'm not a lawyer. So all of the things that you'll be seeing and hearing today at our webinar, then you need to consider that this is not like a law explanation. This will be introducing an explanation more from like an architect perspective, technical leader. So explaining you all of the techniques and all of the patterns that you can use. Yet each case is different, each business domain is different. So I really encourage you to talk with a lawyer or security officer before applying all of them. So yeah. Let's start with the magical acronym that wakes up us, or at least some of us, in the middle of the night. So GDPR is a General Data Protection Regulation, and it came alive at 25th May 2018. But of course, the discussion started earlier. And we can say that, yeah, that came directly from Europe. And we don't need to care if we are not living in Europe or if we are not doing any businesses in Europe. Well, that's partially true, because it appears that not only Europe is taking care about the privacy and in general data and how we are treating customers, but also soon after Europe, the California brought their own act. We also have Canadian personal information protection. We have also Children Online Privacy Protection Act, and even in China, there is a personal information protection law. In fact, if we have a look on this map, then it seems that more and more countries all over the world, on all continents, are taking care, or at least starting to take care and making a formal decisions and formal regulation about privacy. And I can say that even more are discussing that right now. And those that are already introduced those regulations, they are thinking about enhancing them, about making them more bulletproof. So this is just the start. So why do we need all of those regulations? Someone can say. And of course, those bloody hackers, right? If there are no hackers, if there are no people that would like to steal some information or break our computer systems, then we wouldn't need all of those regulations, right? Even from the recent months, we had a lot of exploits or breaches, like Log4j, the most popular logging framework in Java land, like recently, Lapsus hacking group hacked Microsoft, Okta, etc. So we have those breaches popping out almost every day. So that's why we need all of those regulations, right? Well, it appears that no. And because the issue is in us, because it's security and security of the information that people put into our system is just the only one layer of privacy. It's like if you have a look on the message on the mobile of your wife or your husband, then are you breaking a rule or are you breaking a law? Maybe, but usually it's about just caring about and asking whether what you are doing is right, and if your users understand what you want to do with the data. So let's have a look on some companies like Cambridge Analytica. It was scanning the social network information and even impacting the changes in the government like USA or Brexit, etc. So that's already happening. WhatsApp and a lot of messaging platforms are just selling the information of the chats that you are giving to sell more ads. So is it fine? And recently, even Europe is starting to take care about tracking sites. So already Safari and iPhones are blocking a lot of privacy-related tracking. And it appears that recently Austria decided that, no, it's not fine that you are tracking all of the movement on the website. So that's going to happen. And if you have a look on your page, that on your site or application that you are exposing to users, how is it your opt-in or opt-out or don't opt-in checkbox looking in? So it's not only about the hackers that are trying to steal the data, because then we would have a webinar about the security, but it's also about privacy and whether we are putting our hands directly into someone other's information and private stuff. So GDPR and all of the aspects. So GDPR is the most noisy buzzword and the most noisy acronym. But in general, it's about building trust between our users and ourselves. So people know that they can put their own personal information directly into your system or our system. Not only about making sure that someone steals that. That's a ground level that we are taking care about security, but we should also make sure that what we are doing is in fact what our user thinks that we are doing. So it's about trust, credibility, transparency, and empathy. Of course, if you don't care about all of that stuff, then at least the knowledge that you get from this webinar, then maybe will not put you in the jail. So at least that. And so let's start with the customer rights, or I should say data subject rights, because data subject in the GDPR terminology means the user, so someone that is granting the knowledge, granting consents about what we can do with the data they put into our system. So there are 8 the most important rights that our customer, let me use customer instead data subject because we are about empathy, right? So the first one is the right to be informed. So we need to be able to tell user what data are we gathering and what we are doing with those data. The right of access is that we also need to be able to show user and show all of the data that we gathered so they can make sure that, yeah, that's fine for me. The other thing is the right to rectification. The right to rectification is that we should allow user to change the data that they put inside. And we already had a law cases when one person ran against Google that they would like to be removed or some information about that person to be removed from the Google search. And it appeared that on the court, this person won that case. And now Google cannot display those informations. So the other thing is that's something that is the most commonly discussed and probably will be also a lot of discussed here in this webinar is the right of erasure. So by definition, if we are thinking about privacy and about the GDPR, then usually we mean that, yeah, we need to remove the data. But as you can see, this is just one of the most fundamental aspects of GDPR. The other things are the right to restrict. So we need to be able to select what actions do we allow that the system will be doing with our data, and that we should be allowed to restrict to, for example, say that, yes, we only allow the most important thing to run the system, but for the rest, we are rejecting that. And we also need to be able to grant user portability. So user, besides seeing the data that we are keeping and like seeing the precisely which one, then we should not be blocking the user to take out all of the data and export it to the other one. And we should make it seamless. So we should not make like 100 steps and 100 confirmations before we will send and export all of the data, so they can just move it to some other, like for example, our competition. And the right to object is that we can just object for certain things, so as a users. And also users should be informed, and they should also be able to decide whether they would like to be a part of the automated decision making or profiling. Because nowadays with the machine learning, all of the business analytics and data drilling, we might not want to see like a tuned adverts shown on our site. So let's start with the most common case and the most widely discussed. So the right of erasure. So we should expose and grant people option to erase their data. So for example, they decide that they don't want to be anymore our user, and they would like to clean up all of the data. This might be that they are not happy with our services, but we should not look negatively on that, because it just might mean that, yeah, I registered by accident, or I thought that this is something else, and I care about my privacy, so I would like to have that removed. So that typically means that, yeah, okay, if we are using relational database or any other that can delete records, then we are saying that, okay, we will just then remove your data from the user's table. However, that's rarely the case, because usually the personal information is spread across multiple tables. So usually we have users, user address, emails or notifications that we send to them. They also might contain some private information. And what's worse, quite often we are also putting personal data into application logs. So we can say that, well, no worries, we will make the inventory and we will note on which tables you might expect to have those informations. And that's something that we should, of course, be doing, because what's the PII data? PII is the acronym of Personal Identifiable Information. So as you can see, there is quite a lot of those information. So from the most obvious, like a full name, like social security number or address, but also like images, fingerprints, voice signatures, even IP addresses. And we are putting IP addresses quite often to our logs. And it appears that those are also privacy information, because nowadays, a lot of people having their own private IP address, so you can easily find out in which location they are using our system and who they are. So we need to, of course, make those inventory, understand where we currently keep all of those information, but what's more, we should also think about other data, because PII data is not just so simple like a social security number, because that's obvious that like a one-to-one. But we also, if we gather information about date of birth, place of birth, the address, and some financial information like the bank account or where someone was working, then it may also, just by correlating all of the information, we can still be able to decide who's that person. So that's a warning. We should not be tricky, and we should not be trying to be smart more than just a law, because it's not only about a law, but as I said, a credibility and trust. So we should find out whether the other information that we are keeping are not enough to distinguish who's the person. And that's quite important. Like, let's give you an example. If we are on the technical school, then maybe there is only a single woman inside the class, and that's enough to identify that person. So always we should put all of those data in the specific context. And also, if we gather that inventory and make the notes and understand what data do we have, then we can also fulfill the requirement of the right to be informed. Because if we know what data are we keeping and where are we keeping them, then we can inform directly, even on the website, just list all of the informations that we need and what we are doing with them. So that looks quite easy so far, or relatively easy. So we are getting an erasure request, then we are deleting some records, but well, do we believe that this will be enough? Because there is another danger, and this danger is directly on our application level. If we remove all of those data, then let's think about that, because we put those information for a reason, right? So if we remove all of this information and we don't foresee that we might be deleting those informations, then our application may just be broken, because we will have missing data, missing information. And if our business logic and our architecture is not ready for that, then we are quite doomed. So this is on the top right side. You can see the image, how we are seeing our data. Like, yeah, we are putting them into some tables, into rows. They are quite organized. But in fact, this is how typically our data looks like. So we should not be so optimistic that we will be just deleting records, and after that, our system will be working seamlessly. So before doing that, before implementing that procedure, let's make sure that we are prepared for those data to be removed. And even if we remove that, then we also should run some code tests and verify whether after that our application is working, for example, on test environment. So we should not do like a YOLO and just go on with that. The other idea, how we can tackle that, and that might be easier for that case, is that we can try to do anonymization. So instead of deleting records, then we might be just updating those records. So for example, we had Julia Roberts, and after that we anonymized that, and this is right now Jane Doe. And as you can see, you can some data like red blues, we can keep it, and maybe we can even keep that this is she's a woman. But the rest, it's important to take all of the information that I listed previously and make sure that we are randomizing that, and that this is a really randomized data. So if we change them, then we are not have a possibility to make a reverse process and understand who was that person. So again, not try to be tricky. We are just taking care and building the trust that will be important nowadays. So we can, if we are anonymizing data, then we don't need to anonymize all of the records, because quite often only part of the information is PII. Like if we send email to someone, then we for sure need to anonymize email to whom we send, or we can even remove it. And maybe if we are sending some PII data in the description, then we might need to also anonymize that. But some other parts, maybe not. And of course, application logs do not put PII data into application logs, and you're just, besides being right for the users, then you will be much more sane and secure. I can say that from my perspective and from my experience, quite often the support teams are getting logs with the PII data that we should not be getting. So yeah, that's a warning. No for PII data in application logs or any logs. So again, we can even use some mixed procedure. So some data we will be removing, some will be anonymizing, and all of that sounds right. Okay, so we are done. We can call it a day and define that strategy, right? Okay, but what about backups? Because we were only discussing the current transactional data. And in fact, if we are having backups, and if our strategy is to delete data or anonymize data, then see, something went wrong, and we had anonymized already data in our database. And right now we are restoring backup, and maybe this backup was made before someone said that I don't want you to keep my data anymore. And so if we don't think about that and we just restore backup directly, then it might appear that, well, again, user PII information will be put there. So what we should be doing after backup, if that's our strategy, then making sure that we re-erase users that that rejected their grants for us to keep their data, or we should re-anonymize those informations. So that's something that we should remember, because backups usually are just taking the data as they are and just putting it into some blob. Okay, but what if the erasure request was also stored together with the PII data in the backup? Then we are quite doomed, because if we are restoring those data, then how do we know whether we should still re-anonymize that or re-erase? Then in fact, typically, user constants, requests, restrictions, all of that information should be put into some other database. This can be a simple key value store, but what's the most important is that this is really high fault tolerant, high resilient database, and that's not kept together with the application data. Usually, we can use some a secure store like KMS in AWS or other storage that is natively built for storing the secure information. So we should not be keeping those constants and in general those information together with our regular data. So right now it's all good. So we know that we need to gather some information on what data we are storing, where are we storing them. We should also make sure that either we are deleting all of the personal data or anonymizing those data also after restoring backups. So that's all good, right? That's already sounds quite complex to me. I'm not sure how about you. So feel free to comment. But no worries, we will tackle that. So what about access and portability? So I said that no worries, but let's make those things a bit harder, because access and portability, it means that we should show explicitly user which data are we storing. And besides that, we should be able to do portability and export all of those information. So typically, of course, it doesn't have to be the portability that we will do like immediately. We don't need to do it in such way. For example, if you try to port your data from Google, then typically they are saying that they will send you the report and you will get it on your email. So that can be asynchronous process, but still, as we can see, we might have a lot of correlated data and spread across multiple tables. So that's not the easiest way to handle that, right? And so it's not getting easy. And we should also be thinking like, what data are we storing and what are we doing with it? Because we need to explain that to our users. So quite often it appears that even knowing where we put those information and being able to code some procedure to remove it, it's still not easy to take all of those information out of our database and give that to user. So what we can achieve is that quite popular approach for that case is to store PII data separately from application data. This might be a totally different database. And of course, user constant, requests, and restrictions, yet another database. It doesn't have to be different database, especially it doesn't have to be a totally different database type. It might be just different schema within our database, or it might be some just totally separated tables. So we know that in those tables, we are keeping just PII data, and on the others, they are green. They are not having any PII personal information. And that's also quite good from the other case. If we not only keep this user information separated in the storage location, but if we also encapsulate that in our API, then it will be easier to manage. It will be self-contained because all of the information will be kept together. It will be single source of truth. So we will know precisely where to look for those data. And if we are adding those PII data directly to some dedicated storage, then quite often it's much easier to track what we are precisely keeping in our system. And how can we tackle that within the event store? So the first case, the most general case, like separate databases, is currently different clusters. So we might be keeping a separate cluster for PII data and separate for application data. This might be a valid case, especially if we have like if we return an security application like OAuth provider, etc., and we want to keep all of the users' information together. In my system, we had, for example, a separate dedicated service for guest accounts because that was a hospitality industry, and that was all of the data were kept there. But we don't need to do it. We can also just keep them in a different categories because typically in event store, we can set a prefix in our stream name and define what's that type of information. So we can also select a certain PII categories, and then we will know that, yeah, all of the streams from the certain category will have the PII information. So as I said, this might be how the category looks like. We can also add additional prefix, so we can mark like PII user and then ID. And for the regular, we are not putting any other additional prefix, so we can just name it, for example, project. And by that, we know that all of the information and all of the categories that start with PII will contain personal information, and we should be extremely careful about that. And let's have a look on how the category looks like. So as I mentioned, the main category will be from the event store terminology, this is category. So everything that we put before dash. But we can think about that, and that may come in the further versions, that you will be able to also provide a subcategory, but even now you can do that. So like name PII user, and in the end, this will be entity ID. But beware, and do not try to put PII data as entity ID, or especially into category ID, because those information is we won't be able to erase all of the data, because even if we delete stream or so truncate stream, then this information still be kept. Plus, we will have also all the other issues that we might have. So even if we want to be sure that that we are checking, for example, uniqueness based on some user email data, then let's just use some hash and do not use the real email address. So we can take the PII data and provide a specific hash function that will be changing our email into some hash. And the most important is that hash cannot be reversible. So if it's reversible, then someone can again dehash the data and know what's the user email. So the best is to not try to put PII data as your ID. And let's get back for a moment for the right of erasure. So can we also remove the data into event source system? Because even myself, I said at least multiple times during my webinars that event sourcing, and the main advantage of event sourcing is that we are not losing any business information. So can we erase that? And the answer is yes, we can. So in Event Store, we have a process called scavenging. So it means that we are putting some, we are scavenge some of the information, and we can do that by setting on the stream metadata level. The stream metadata, it's a restricted TB, $TB, and it means that I would like to have removed all of the events that came before a certain position. So for example, if we have a cashier workstation, and we can see that we have a cashier shift, and for example, after each cashier shift closed, we would like to remove and truncate all of the information before. So we can change what we see at the top into the stream at the bottom. And the most important aspect about the scavenging process is that it's not happening immediately. So if we set the truncate before on the stream level, then of course you won't see those events if you'll be reading from the event stream. However, if you subscribe to all stream, then all of the information will be still there because they are not physically removed before you are doing scavenging process. So if you want to be sure that all of the PII information were removed, then you need to run scavenging process. And what's also important is to use the enigmatic option called always keep scavenged. And what that means is that scavenge process in general was built to optimize the event store data storage. So what it does, it's a really shortcut, but we can say that it's compacting the data. So it's going through all of the chunks, so all of the files that event store is creating, and just checking whether there are some data that can be removed. I hope that team or other person that is much more skilled about scavenging process won't be saying that this is too short explanation, but this is in a nutshell, this is what it does. So it just try to reduce the storage. But in an edge case, it might appear that after scavenging the newly created chunk, so the scavenged chunk is bigger than the previous one. And as by default, scavenging is optimized to save space, then if we don't enable this always keep scavenge, then it won't, after scavenging, it won't be keeping the new one, the cleaned up chunk, but the old one, because the old one is smaller. So if we want to be doing GDPR compliance by deleting events, then we need to be sure that we turn on this information. And the other thing is tombstoning, because in event store we can use truncate before or soft delete. Soft delete means that we are deleting whole stream and in fact setting the truncate before as the latest event. But we can also be doing tombstoning. And tombstoning means that we are saying that this stream, whole stream, should be removed, and we are setting some specific tombstone over there, so this stream cannot be recreated anymore. So that can be quite useful for the cases like someone decided that they don't want to be anymore our user and that they would like to request to erase all of the information. However, we still might get his information from other places. Because quite often, for example, our company bought another company and we are unifying some data, and that person was also a user of the other one. And if we are unifying those information, then we should still be able to say, like, yeah, this specific person decided that they don't want to have their data anymore. So if we are unifying, merging, or importing other data, then we still should not be recreating them. And if we are using tombstoning, then immediately we just physically won't be possible, because even StoreDB won't allow us to create a stream with the same ID. So if we use some predictable hash, and for the specific email we will always get a specific hash, then that's something that together with tombstoning might give us the option to make sure that we are also handling the properly case where it's importing. And the other thing is the right of rectification. So as I mentioned, by the right of rectification, we need to make sure that someone can overwrite all of the information that we keep about them, because they decided that, no, this is not information that I would like you to keep, but I would like to override them. And by default, in the events sourcing and event stores, you cannot overwrite data because you cannot modify them. So even if you append a new event with the new information, then technically you are still keeping all data in older events. So if someone is doing like an official rectification of their data, then what we should be doing is to append new event and also truncate all of the previous events and all of the previous information that we had about that specific person. And truncating will help us on that, which is cool. So again, that's what we told. But in general, all of the things that I'll be telling you, it's not something that is extremely created directly for the GDPR purposes, because is it only GDPR or privacy that we would like to know what our system are doing or what data our system is keeping? That's something that's a part of governance and compliance, and even quite often some other rules and some other audit requirements. Then all of those things are, in my opinion, something that we as developers, leaders, architects should be taking care of, because that's making our system stronger. It's building the trust not only in our users, but also inside our company, that we know what we are doing and know what we want to achieve. And also, we can say that, yeah, truncating, deleting events, losing information inside event store in event sourcing is something that is not by design. And in fact, it is by design, because if we quite often we are trying to keep all of the informations that are useless for the regular use case. So for example, if we have this cashier shift, So if we keep all of the information about all of shifts that happen for the particular workstation, then is it really needed? Like maybe it is, but for reporting purposes, but for the transaction and current regular usage of the and processing new new things that people are buying in the shop, it's not important. What we care is only about the current cashiering shift and all of the transactions that happen during them. So it's perfectly fine to truncate or archive some information. By archive, I mean that we can take it to some other storage that might be some dedicated other event store cluster, or it might be some blob storage if we only need all of those old information for audit purposes, or we can move it to, for example, Elasticsearch or other database that is built for like searching for logs, because maybe for older cases we just need to have searchability and read-only access. So we should not only be caring about the length of our streams and erasure and archiving strategy because of the GDPR rules, but because we would like to use our tools properly and make proper architecture and proper design. So GDPR should not be a case for us by itself, but it should be also motivation to strengthen our internal processes. And okay, we discussed that we can erase, we can anonymize. Of course, we cannot anonymize that in event store because events are immutable. However, this is not the whole story, because if we are storing events, then typically we also want to publish all of those events. And we want to build, for example, read models on other databases. Quite often we would like to forward it to some other queues like Rabbit, Kafka. And even if we are not using Event Store DB, even if we are using regular database, then quite often, if we are doing microservice approach, event-driven approach, then we are publishing also data to some other or exchanging messages between systems. And after that, if we publish those events and someone get them, then we already then we are already losing control over that data. So the most common case and the most common idea on how to deal with that is to publish information to other services about the erasure. So that someone requested that we erase all of the information and all of the data that we keep inside our system. So we should publish this event, and all of the other streamlined services should handle that and clean up all of the data on their storage. So it's not like we can just think about GDPR on the main database or on our write model. We should be also taking care of all of the read models or of the external integrations. And those external integrations are in fact the hardest part, because let's see all of the guarantees that we would like to give to our users. So for example, the right to be informed. Of course, our external system can inform us and we can inform our users. But the biggest question is whether we can trust this external system. So we need to be really sure, and we need to double check that this tool and this external system is trustworthy. So that's also the reason why we in Event Store DB, we are going with the Event Store Cloud with all of the certifications. So we recently got ISO and SOC 2 to just ensure that if you store data in our service, then we won't be doing any weird data. We won't grant any access to some unrestricted people, etc. So that's really important, and that's something that we should be doing. We should not see just, oh, well, this is nice external system. that will be doing some transformation of the user data, so I don't need to write my own case. And that might be a perfectly valid decision, but we need to be sure that also those providers take care about the privacy standards, so that they also fulfill all of those things. Because when we send the PII data to external system, then we are just losing control. And we also need to explain our users and show all of the systems that might be getting those their information, their personal information, because even if we trust this external system, then our users might not trust them. So that's really important. And we also, by this the right to restrict, we should give user option to restrict sending those information externally, because they might be fully trusting us, but they might be suspicious for all the others. And one of the things and one of the patterns that you can use also with events, so how to send those informations. So instead of sending all of the PII information, like here, so this is our event, as you see, we are sending name, organization, birthday, hobbies, etc. So we are sending to all of those services, we are sending also the PII data. Then Matthias Veres wrote the nice description of this pattern on his blog. And instead of sending all of those personal information, we can be just sending the link. And the link will be, for example, URL to our public API of our system. So then it's less probable that someone will just cache those information. Yet, of course, if someone gets events and then requesting to our service for this data, then again, we don't have any control of what they do with this information. So when they do query, they might be just using it for this particular business logic and not storing that anywhere. But then, like, our other team might decide that, well, we will cache that somewhere, and we won't even be knowing about that. And if we are doing for the external system, then again, we know. But in the positive case, that we know that we are following those procedures, so someone, if they need to, for example, best option for need to is when we need to just display those information. So we won't be storing, but for example, we want to get the dashboard that shows not only data from our system, but also from external and together with the PII data, then we might be just calling additional service and gathering those information and then joining them together. So if the data is erased, then we have plenty options. We can, as a authority of the PII data, then we might decide to, for example, return some anonymized data. We might return partial data, so only we return those no PII data, and for those personal, we are just returning null. Or we can just decide that, no, this whole information is not available anymore. For example, we are just erasing all of the profile information. So is it looking a bit better? Maybe, but it's still quite complex. So we need to remember about a lot of stuff. And even if we are extremely cautious, if we have the best plan, if we wrote all of the information and all of the operations that we are doing on the data, then still the new feature might come up, the new colleague will just forget about the procedure, and then we have a privacy information leak. And that's something that we don't want to have. And for that, the potential scenario is to use crypto shredding technique. This, I'm not sure how about you, but for me, shredding, it's always reminds me of Shredder. I was a huge fan of Teenage Mutant Ninja Turtles, and this anti-superhero there was one of the best characters. But nevertheless, let's go back to the real world and to the crypto shredding. Crypto is not about Web3 or Bitcoin or mining anything. It's about the cryptography. So what we are doing here is that before we store information directly into the event store, then we are using some encryption key store. Usually, and what I recommend is to not create such store on ourselves. Best is to not keep all of those information in the regular file storage that anyone can access. There are already tools like HashiCorp Vault or any other cloud native clones. Each cloud provider has their own vault, so own secure encryption key store. And for that, we are just taking the information, so data with the event, and then during the serialization process, because event store DB in the end is just storing bytes. Even if you are using JSON, then this JSON is serialized into binary format, and in event store DB it ends up in the binary format. So some clients like Node.js, Java provides a built-in JSON serialization, but they are just a syntactic sugar on top of it. If you are using, for example, .NET client, then you need to handle serialization on your own, so you know that already. So we are taking this event and we are selecting which data is PII. So in this case, for example, name, birthday, this is PII data. And as you can see, previously, initially we had Joe Bloggs and 1984. And here we are getting some randomly looking string text. And those are already encrypted data. So this encrypted data we are just putting into bytes and then just putting directly into event store. So this is quite similar to the technique, to the forgettable payload that we saw previously. So instead of just those PII data, we are changing that to something else. And in this particular case, we are not changing that into a link, but some encrypted string. And after that, we are storing the event data directly into event store. And if we are getting events from event store, then we are getting the same events that we store. So as you see, we are not changing, not modifying any information. So it's perfectly legal from all the audit procedures, etc. And we are keeping event store DB agnostic from that part. So event store only knows that, yeah, this is event. And after that, and maybe let's just discuss a bit briefly, jump in to some other GDPR terms. So you already know data subject, right? So it's a consumer or user. Data controller is your company and your system and or precisely you. So data controller is someone that is just controlling the data, doing something with the data that data subject, so our consumer user gave us. And we have also data processor. So data processor might be also data controller, but quite often this is also a storage service. So if you are using any cloud provider storage, or for example, our managed service, then we are data processors. And it's quite critical to know that data processors are doing stuff on behalf of the data controller grants that they get from users. So it's quite important to be sure, again, that data processors are taking care about privacy. So that's also important in this particular case, because event store is just data processor. So it's processing data. By processing, it means that you can put it into event store or you can take it out. But we are not changing any data, not looking on your data. So that's why is it important, and that's why is it a benefit that the crypto shredding technique is agnostic to event store DB. And So when we want to get the data from the event store and decrypt that, then we are taking data, we are taking the person ID and searching for the encryption store for this particular certificate. And we see that, yes, we have certificate for this particular person because each person should have their own certificate. And after that, we are taking this certificate, deserializing, decrypting the data, and again, from this magical data, we can get again our information that we store, so job logs, etc. However, if it appeared that the certificate was already deleted, then PII data won't be deserialized. So crypto shredding technique in a nutshell is that we are putting each person will get their own certificate. We will use this certificate both for encrypting event data and decrypting event data. And if someone decides that they would like to have all of the data erased, then we are just erasing the certificate. So after that, if we don't have certificate, then we cannot technically decrypt those information, and we won't have as a, again, as a data controller, so I'll be able to get those PII information. Of course, let's reiterate, that's also why is it important to keep those certificates in the secure key store and to restrict the data, access to this key store, so it cannot be just regular developer cannot have access to user certificates, and to be sure that we are not just looking at the data. But after this certificate is deleted, then everything is erased, and that's fine. And as you see, we can have those information not available. And what's quite important is that we can select only a subset of fields that we would like to remove. So for example, during the deserialization, we can decide that whether those fields should be returned with default value like null, or maybe we would like during deserialization to put some random data each time we are getting this event. So it's perfectly valid because we can still use person ID and we can still use those information during the aggregation process. We can use those data in our projections. When we got the erasure request, then we can publish information about that we should also remove all of the other PII data, or we can even use this encryption store and also store encrypted data directly in our read model storage. So we have plenty of options. Crypto shredding is not only limited to event sourcing. And in general, the leitmotif of this webinar is to show you that event sourcing in general is not special around GDPR. The only thing that we cannot do is to modify data. We can do it partially, but during the serialization, as I show in the crypto shredding technique, but in fact, we are not modifying this data. We are just masking the information, the encrypted data that we cannot decrypt anymore. So if someone asks me whether event sourcing and event store are extremely special for the case of GDPR, then no. All of the techniques that we discussed, so like anonymization, like potentially removal, like making sure, and all of those steps, like informing other modules, making sure that we trust our external systems, everything is precisely the same as we would like to go from the regular system approach. What's different is, of course, some techniques that we, for example, need to truncate stream, how we need to truncate, but each tool has its own specificities. So So I think that crypto shredding in general looks simpler than that, because it might be easier. Of course, we still need to have the inventory of all of the data that we keep. We need to still monitor all of the workflows and what we are doing, but it's much easier to restrict the usage by crypto shredding, because if we remove the certificate and all of the services are using certificates from the specific secured key store, then after we remove certificates, then immediately they won't be able to decrypt the information. So if we are consistent, then even if we don't put this new data, a new process into our inventory, then still by using crypto shredding, we will be fine. And what about backups? Yeah, crypto shredding is also better for backups, because if we keep the encrypted data inside backups, then if we restore backup, then again this data will be encrypted, and we won't be able to encrypt it anymore. Of course, it's not like perfectly case, because if we publish all of those events with the PII data and some service had access to the secure key store, decrypted the data, then we are not sure whether they didn't put it somewhere like in a S3 storage. But that's something, and that's also a part of the process that we should be creating, a governance, a compliance process that we still need to be applying and be making sure. But this is not only about the GDPR, but how to create a proper production-ready systems. So for the external system, then for example, we might just not grant them access to this personal data, so to the key store. That's in general best idea, to not give them access to such critical privacy settings. So maybe as we are on the development webinar, then let's try to see some code and how to practically apply the crypto shredding technique. So let's start with some example events and what we will be trying to hide. So we have some basic information, like the contact was added. Let's say that we have some CRM system, we have address information, and we have also event that this contact booked some meeting with us. So as we can see, the contact added contains already some PII information like name, birthday, address might be PII or might not, but typically it is. So we can also mark it with the personal data. And what we also have and what we also marked is this data subject ID, because data subject ID, we need to know which specific property is used to get the certificate for the specific event, because we need to know which certificate to use to encrypt or decrypt the specific event. And here, as you see, this is some dummy data. Let's say that this is just a contact ID, and contact ID, if it's good, if it's not email, then it's not PII data, we can still keep it. So this event won't be encrypted or decrypted at all. And the base logic is like we are creating some events. As you see, we are setting some ID of the specific record. And in the end, we just want to persist all of those events somewhere in some stream. And we would like to have all of the personal information that were marked with those attributes to be encrypted. So let's see how to do that. In general, if we have a look on the persist events method, then it's nothing special. We are just calling the regular event store API. We can use some optimistic concurrency, and we are putting events data. So there is nothing special here. Again, if we are reading stream data, then again, we are saying that we are reading whole stream from start to end. We are also getting those events. So this API is not looking extremely pushy. There is nothing special here about about crypto shredding. So that's also a proof that that event store is just agnostic to that part. So how are we doing that? Then we have like an event converter class. And event converter class, what it will be doing is to serializing or deserializing our event data. So if you are .NET developer, then this code may look already similar. So we are just using some serializer and either deserializing event if we are reading it, and serializing it if we are storing it. So far so good. Nothing spectacular here. Nothing about the crypto shredding. So the magic that we have is happening in the JSON serializer, because in the JSON serializer, we are putting a class that is magically called Encryptor Decryptor. It's kind of explicit and looks funny, but still it says precisely what it does. So it just it just tries to get from some secure key storage certificate. Then we are using here AES algorithm, and it's also really important to use some strong cryptography algorithms. AES, for example, at least 256 bytes. So again, we are getting the certificates from some secure store. Then we are building the AES class, which is native .NET class. And for Decryptor, we are doing the same. We are trying to get certificate for the specific person. If the key was deleted, then we are just returning that we cannot do anything. And if yes, then we are creating Decryptor that will be used for encrypting and decrypting events. Where are we plugging this class? So we have JSON serializer settings factory. Sounds really enterprisey, but what it does is that we are injecting this class that is responsible for getting the certificate and creating the .NET class that will be decrypting for reading and encrypting for storing. And we are building JSON serializer settings. We are using here the JSON.NET. For the system text JSON, you can do similar stuff, but coded a bit differently. So for the Newtonsoft JSON.NET, we can define a contract resolver. And we can decide that this will be a contract resolver during serialization and the other one during deserialization, because this process will look a bit different. And we are saying that while we will be either serializing some object or deserializing some binary data, then we will use this specific contract resolver. And this contract resolver, what it does, it just builds definition of the specific type. So for example, contact added. Let's again have a look at the contact added event. As you can see, some of the data should be encrypted, some not. Like aggregate ID, person ID should remain as it is, and country code in address may remain because it's not PII data. It's not enough to say that someone is from Poland or Germany to say who it is. So that's fine. And we are getting all of the properties. And we are doing for each and checking whether this property contains a PII information. If it doesn't contain, then we are just using the default logic for handling serialization. And if it is the PII data, then we are using some specific encryption converter. And this encryption converter will use the Encryptor class, so the one that gets certificate and use the native .NET support. And then we are sending the information about the field encryption. So by that, we'll see later what it is. So to verify whether this property contains PII data, is we are getting property info. Then we are checking whether this property has the personal data attribute. So precisely like our, for example, name and birthday. And if it does, then we are saying that, yeah, it is personal data attribute, and we should be encrypting it. And what encryption JSON converter does, it just tries to just perform the encryption. And encryption is just like a bit fancy logic, but nothing spectacular. We are just taking the certificate. Here we are building some stream, changing data memory stream into encrypted text, and in the end we are just returning the data. Sorry, it's here. And for the process is the other way round. So if we are trying to get decrypted text, then again we are making sure that this property is in fact encrypted. If it is, then we are just either returning the information if we have certificate, or if we don't have certificate, then we are trying to use masked value. And this is the place where you can put like some hashed information, or for example, knowing that this is name, then we can replace Julia Roberts with Jane Doe. So this is happening here. So if we have some custom logic on how to mask it, then yeah, it's fine. So this is exactly the same case for the serialization. So if we use decryption converter, then it does the reversed process. So deserialization, it's also just taking all of the property, checks whether that's something that we should be decrypting, and either, depending on our strategy, is returning some specific hashed data, masked data, or just default value. And that's all. That's simple as it is. So are there any questions about that technique or about the technical implementation? Should I explain something again or show some bits specifically? Okay, so if not, then let's think like, what if someone breaks our encryption algorithm? Because that's already happened. Like some of the old RSA are already not secured. So that might happen in the future. However, with the current technique, those currently the most secure encryption algorithms will take a lot of time before they are busted. And if they are busted, then we can use the copy and replace strategy. Because if this encryption was already busted, then we can do copy and transform. We can get all of the events from the event store, run some transformation, so we can just even remove the data on the flight while we are sending it to some other event store cluster, and then store data again. And if we already know how to handle this busted algorithm and we can decrypt it, then we can also encrypt it again. However, we can already, if we know that this is already busted, then we can perform some anonymization. And in theory, this is also a technique that we could use to anonymize all of the information during the erasure request. However, such technique, let's say that this is like a really trying to shoot the pigeon with the rifle, because we would need to take all of the events and all of the information that are put inside our event store and rewrite them. That might be fine. However, it won't be precise on the point when someone wanted to erase that. So this is not ideal. I would leave it, this strategy, for this particular privacy thing, for the more common and more harder case like this one. So for example, some cryptographic algorithm that we use was busted. So again, I hope that I managed to persuade you that GDPR is not so scary. It might look scary, but in fact, we should always think about compliance, about data governance, about privacy, and just not making evil. Because that we are getting credibility in our customers, trust. We are also showing the transparency, which is also critical also for us when we are building our systems. And it's better that we know what are the rules, what should we do, and how do we care about that, how do we handle that. And so all of those customer rights, so the right to be informed, the right of access, the right to rectification, erasure, restrict, portability, object, and profiling, are in fact procedures that we should, even if there is no GDPR, then if we want to build a proper system, then we should be taking care of. And even though those strategies might be looking like a black magic, but if we are consistent in our approach, then they are not so hard as they seem. We can use some anonymization, we can delete data, we can keep different databases, so separate totally PII data from the application data. We can build autonomous, self-contained service that will be responsible and will make easier for us to handle those privacy stuff. But in the end, it's like to not be baddies, just do not make evils, because we wouldn't like to be like that, right? And if we don't care about that, then at least I hope that those information and those techniques will help you to not go to jail. So that's all from me. Thank you a lot for watching this webinar, for being here. I encourage you to read Diego Martin post. So all of the code that I showed about crypto shredding was created by Diego. It's available on our blog. And as always, I would like to do you have any questions or maybe feedback? Do you like it? I hope that you enjoyed. And yeah, besides that, that's all. So just don't be evil and just care about ourselves, about our users, because that just pays off in the end. So thank you a lot. If there are no questions, then have a nice evening, have a good day, and see you. Bye.